Please welcome software engineer from Google, Alex Feinstein.
Hi, thank you. So I'm Alex Gruenstein, and I apologize. I'll be speaking in English today, but if you put on your headset, hopefully I won't speak too fast and you'll be able to understand some of what I'm saying. I'm going to be talking today about speech recognition in general, and in particular the speech input API for Android. I'll have some help from my colleague, Yusuke Konishi, who will be doing some demonstrations for you in Japanese. So I'm going to talk today first, give an overview of some of the speech recognition features which are built into all Android phones. I'll give a very brief primer on how speech recognition works in general to try to help you as a developer understand some of the key points for when you're building an application. Finally, I'll give a brief how-to on how you can integrate speech input directly into your Android application with literally just a very few lines of code. So that'll actually be perhaps the shortest section of the talk. So let's start talking about speech recognition and what Google provides on different mobile phones. So sort of our flagship product is voice search, which allows you to type any Google search query into your mobile phone. I'm sorry, to dictate any Google search query into your mobile phone, just as though you were typing, which hopefully will make your life a little bit easier. Currently, Google Voice Search is supported on a variety of platforms: Android, iPhone, iPod, iPad, BlackBerry, and the Nokia S60. And at the moment, it's supported in 15 languages, several different flavors of English, Japanese, Mandarin, Korean, Taiwanese, French, Italian, German, Spanish, Russian, Polish, and Czech. And we are rapidly working on expanding that list of languages. So hopefully you see your favorite language there already, but if there are others you're interested in, hopefully they'll be coming soon. So just to give you an idea of how voice search works, I'm going to invite my colleague up onto the stage so that he can give you a live demonstration.
こんにちは。Google でソフトウェアエンジニアをやっている小西祐介です。今から、ボイスサーチを、使うだけのデモをします。はい。皆さん Android の携帯を持ってますよね。はい。Android のそっか電源を入れないとすいません。Android のトップ画面にこういう風なサーチボックスがあって、今まではここをタッチしてここをタッチして検索キーワードを入力してたんですけれど、まあそれをするのはこうやってタッチして、キーボードでタッチするのはめんどくさいと。で、声を使った入力が、新しい Android ではサポートされています。はい、では今からちょっとやってみます。東京国際フォーラム。
Usually there's no need to shout.
で、この東京国際フォーラムと、長いタイプをする必要がなくて、この周りの情報を調べることができます。また、さまざまなクエリに対応していて、人の名前、場所、普通の、一般名詞など、さまざまな、クエリに対応しています。例えば、最近有名なあの人の情報が知りたいというときは、このように、最近でもないですね人の名前を入っていますと。他にも、今晩どこでご飯を食べようかなという時などには 楽町、ディナー、イタリアン。とこのように複数のクエリで検索することもできます。結構便利な機能なんで、皆さん恥ずかしがらずに使ってみてください。よろしくお願いします。
Thank you very much. Our team has been working on going beyond voice search, and one of the next projects we've been working on is called Voice Actions. Unfortunately, this is currently only available in English, so I can't give you a demo in Japanese. But the idea is that from this very same microphone button on the home screen that he was pressing to do a voice search, he can speak a number of different actions in order to, for example, send a text message, send an email, navigate to a particular location, listen to a song, or go to a website. So for example, I can just tap that button and say, send text to Claire Humberlin. Hey, are you coming home? And I'll get the screen here on the right. And I can correct my utterance. I can correct the message. And if I'm happy with it, I can press send and send that text message without ever having to go into the SMS app. A third feature which we put into Android that makes use of speech recognition is, again, goes beyond search, and it's called Android Voice Input. Voice Input allows you basically to speak anywhere that you would type. So you can go into any application on Android. You can tap on the text field you want to type into. The keyboard will come up, and then you can just press this microphone button on the keyboard and dictate whatever it is you want to go into that text field, just as if you were typing. So for example, you can do status updates, Twitter, SMS, email, etc. And I just thought I'd show a quick video of this, unfortunately in English, just to give you an idea of the power of the feature.
Introducing voice input to the keyboard on new Android phones. Now you can speak, and the phone types for you. You can start up voice input from the keyboard in 2 easy ways. Press the microphone button. Hi there. And as you start talking, your words appear in the text input box. Or, without looking at the keyboard, swipe across to start voice input in 1 stroke. Sounds good, period. Where are we meeting, question mark. Speak your punctuation, and voice input will recognize it as well. You can also switch to text input whenever you want. Voice input works with any application that has text fields, with the exception of password boxes. Beethoven. It even works with your status updates. I love my new phone. Get voice input on new Android-powered phones. For further information and videos, visit our channel on YouTube.
So hopefully that gives you a little bit of an idea of some of the speech recognition capabilities that we've been trying to build directly into Android in order to make it a mobile platform that's very easy to use and one in which you can do drastically less typing than you had to do before. So I thought I'd give a little bit of a primer on how is the speech recognition working on Android. One key point to keep in mind is that when the user speaks, and for instance, they see this microphone button, they see this microphone icon, all of their audio as they speak is streamed to Google speech recognition servers. Now, at the moment, depending on the setting of your phone, we take that audio and send it to an appropriate server for your language. So if your phone is set to Japanese, you'll go to our Japanese server. If it's set to US English, you'll go to our English server. And so on for all of the different languages we support. Inside each of these servers are a number of important components which make speech recognition possible. I won't go into all the details on them, but I just thought I'd talk briefly about some of them. So there's an acoustic model, a dictionary, and different language models, which we use in order to make speech recognition possible. Each of these is a stochastic model, and they're layered together in order to come up with the best hypothesis for what you said. The job of the acoustic model is to break the audio that we hear into small phonetic units. So for example, given a waveform of a person speaking, we break it into very small little chunks in time. And I'll call these here T0, T1, T2, etc. The job of the acoustic model is to try to identify probabilistically what phonetic unit occurred at that point in time. So for example, if I said the word red, the acoustic model might hypothesize that at time T1 it heard because I said red, with a high probability 0.7. Or it might also hypothesize with a much lower probability here, 0.3, that I said read, and it'll hypothesize E there, the sound E instead of eh. So as you can see, to develop this acoustic model for different languages, it's very important to have audio information for every different language that you want to build a model for. Similarly, the dictionary maps words into these smaller phonetic units. So for example, it might map the word read into two different pronunciations, read and read, because in English you can say, if you read that word on the page, you might pronounce it either of those different ways. Depending on which one is more common, we might assign a higher probability to one than the other. Finally, the language model gives me a probability of word sequences. So the language model doesn't know anything about the acoustics of the language, but it looks purely at what word sequences are likely to occur in that language. So for example, I would want my language model to tell me that the probability of the word sequence read a book is much higher than the probability of the word sequence read a flower. Because given no contextual information, no acoustic information, we know that people are much more likely to say read a book than read a flower. It's just a much more common phrase. How do we build these models? Well, because each of them are stochastic models and involve probabilities, we use training data to estimate these models. So for example, to build the language model for voice search, we look at billions and billions of Google searches from our logs, and we simply count up how many times each one of these different searches occurred. So for example, in English, we might have users searching for the Museum of Modern Art, the Beatles, pictures of the Golden Gate Bridge. And we'll have billions and billions and billions of instances of these search queries. So in order to estimate our model, we count not the number of times each query occurred, but the number of times short sequences in those queries occurred. That makes the problem more tractable, and it also allows me to estimate probabilities for queries I've never actually seen before. So there's going to be some long tail of queries that nobody's ever going to have typed into Google, but then somebody is going to speak that query. And to be able to estimate that, if I have probabilities about smaller word chunks within that query, I can get an estimate for how likely that query is overall. So for example, to estimate the probability of the San Francisco Golden Gate Bridge, I can break that into 3 word sequences: San Francisco Golden, Francisco Golden Gate, and Golden Gate Bridge. And I can piece together these 3 probabilities that I've estimated for these 3 short sequences to get a probability for the overall sentence. Now, when you're processing billions and billions of query logs, you can imagine that simply counting and doing the smoothing of the probabilities that's required takes many, many hours, even spread across thousands of computers in parallel in our data centers at Google. Okay, so that's should give you an idea of how speech recognition works in general. Now I'd just like to give a primer on how you as a developer can better integrate speech input directly into your Android application. So Android's open platform makes it simple to access Google's speech recognizer. So because Android makes it very easy for applications to communicate with one another, we've tried to make the speech recognizer very easy for other applications to communicate with. Or for that matter, anybody who builds a speech recognizer for Android can simply make it, implement the same interface. It's a public interface, this recognizer intent. And then other applications could use that recognizer instead of Google's. It's very simple to use the API. With just a few lines of code, you can prompt the user to start speaking. What the user says will be streamed to Google's speech recognition servers. And then you'll easily be able to retrieve the recognition hypothesis. So why would you want to do this? Well, to give you an idea, let's look at a couple of my favorite example applications. So these are actually applications that third-party developers have written. I had nothing to do with them, and I downloaded them from Market just like everybody else, and I've been using them to see how other developers are making use of speech recognition. So one of my favorites is this application called Hand-Sent SMS, which basically supercharges the way your phone handles SMS messages. One of the things it does is pop up, anytime you receive an SMS message, it pops up a screen here with the message. And my favorite feature is that if I don't want to have to tap the field and bring up the keyboard, I can simply tap this microphone button, which the developer has put directly in the application. And then Google's speech recognition server will kick in, will show a prompt, the user can speak, and then when we come up with a hypothesis on our servers, the developer can just stick it in the appropriate text field. And if I like it, I can just hit reply. So that's a good example of something a developer's done to make it even easier. So of course, the user could tap on the field, bring up the keyboard, and then use the microphone button we've built in to dictate, but this makes it even easier and saves you a few steps. One of the sort of more fun example application is another one available on Android Market called Practice English, and some of you might be interested in this. It's a very simple application. It goes through a number of different English words, shows them to you on the screen, and then you tap the speak button here at the bottom, and you speak the word that you see on the screen. Now, if our speech recognizers happen to be able to understand you, then you'll get 1 point. And if we can't understand you, then you won't get a point. So I don't know if it's more of a test of you or our speech recognition servers, but it's kind of a fun game. So I'd like to invite my colleague again to come up, and he's been kind enough to put together a very fun demo in Japanese, and I'll let him demonstrate it.
はい、で、ボイス API を使ったら、別に、そんな、インプットテキストに何かものを入れるだけじゃなくて、もっといろいろ面白いことができるはずだということで、今日はちょっと1個デモアプリケーションを作ってきました。拡大ってどうするのかな。これかな。はい、この子はとても賢いので、僕のうちのペットです。はい、で、この子にいろいろ命令をするとちゃんとその通りに動いてくれるというデモを今日は作ってきました。動かなかったらごめんなさい。はい、じゃあいきます。 ちょっとドッグフードが足りなくてちょっとご機嫌斜めですね。帰るのが合ってますね。まあこんな感じで、いろいろ、ボイス API を使ったら面白いアプリケーションが作れるはずなんで、ここにいる皆様デベロッパーですよね。作ってみてください。今までこんなアプリケーションを作ろうと思ったら結構大変で、まあできないことはないけれど、ものすごくコストがかかってすごい作るのが大変みたいな感じだったんですけど、まあこのボイス API を使うとすごい簡単にこういうアプリケーションが作れるはずで、これは1日か2日ぐらいかけて作ったんで、ものすごく簡単です。皆様ぜひ作ってみてください。そして面白いアプリケーションを作ってください。よろしくお願いします。
Thank you. Well, I'm not sure what's smarter, the dog or our speech recognizer. So I guess you can see that application in some ways kind of pushed the limits of what we can do by trying to listen all of the time. So I'd encourage all of you to try to push the limits of what we can do, so that you can push on us to build a better product. So we'd love to get your feedback. We'd love to see your applications in market, so that we can figure out how to help you develop better applications. So just at the risk of getting a little too technical, I hope many of you are developers and maybe have seen some Android source code before. But here I've put on the screen maybe the simplest application you can build using the speech API. And I hope, as I promised, it's just a few lines of code, maybe 4 lines of real code here. So just to walk through it, this is an example of an application you might write, or a function you might write to respond to the user clicking on a button in your application. So if you want to invoke the speech recognizer, it's pretty easy. If you're familiar with Android, you just construct a new intent, and the type of that intent is action recognized speech. So as I said before, intents are a way for Android applications to communicate with one another. So we're going to build this intent, and we're going to send it actually to the voice search application so that it can perform speech recognition. We can set different parameters on the intent. So here I've set the language model, and by setting it to language model freeform, I'm indicating that I expect the user to do dictation. So for example, I expect them to maybe dictate an SMS or send an email. Once I've set all the parameters I want to set, I can send this intent to the voice search application, or as I said before, to any third-party speech recognizer installed on the phone with just another line of code here. So here, voice search will bring up the dialog box to prompt the user to speak. The user will speak. The audio will be sent to Google speech recognition servers. And then once we've processed the audio and we have our best guess, we'll call this onActivity result method. This method returns not just our best hypothesis, but actually a ranked list of our best hypotheses, something we call an nbest list. If you're just interested in the one we thought that was most probable, so for example, let's say we think the user said Golden Gate Bridge, then we'll grab that from the top of the list, and then here's where your job comes in. You have to do something with the results. So you have to build a function to actually do something interesting, make a dog sit up or shake your hand, or give you a point in the practice English game. So let's talk a little bit about the parameters you can set. So one of the most important, of course, is the language. So I wish I could tell you that users will speak and will automatically identify the language, but we're just not there yet. So at the moment, you have to tell us what language do you expect the user to speak. And you can do this through the parameter called extra language. So for example, if you expect the user to speak in Japanese, you send us the code for Japanese. If you expect them to speak in US English, for example, you could send the code for US English. Oftentimes, you don't have to set this. If it's not set, then whatever the phone's default language is picked up. And in newer versions of Android, you can actually, the user can explicitly go in and choose the language that they want to use for voice recognition in the settings. The other parameter, which I had in my example, was called language model. It's extra language model. And you can specify two different parameters at the moment, search or freeform. So search will basically give you the same language model we use for our own Google Voice Search product, which means it's basically good for anything. It's very well tuned for if you expect the user to say the types of things they might search for on Google. Things like businesses, cities, names of celebrities, just anything you might search for on Google. Freeform is for dictation. So if you expect the user is sending an email, sending an SMS, et cetera, then you might want to use dictation. So I've talked a bit about Google Speech technology as it applies to mobile phones, but since you're here, maybe you're interested in some of the other things we're working on. So I just thought I'd briefly mention them. Our other big projects are automatically subtitling YouTube videos. So we listen to what people say in the YouTube video and come up with subtitles automatically for it. The really cool thing about that is that you can then run those subtitles through Google Translate. And so, for example, you could take an English video, add subtitles automatically, and translate them to Japanese so that you could go to YouTube and watch any video in English with Japanese subtitles. Now, I'm not going to claim they're perfect. There are speech recognition errors, there are transcription errors, but often you can get a pretty good idea of what the video is about. The other big product we're integrated into is Google Voice. So this is a product which I think right now is only available in the US, but it's basically a product for sort of supercharging the way voicemail and SMS messages work on your phone. The role we play there is that if anybody leaves you a voicemail, we'll automatically transcribe that voicemail and then email you the transcript. So oftentimes, I actually don't have to listen to my voicemails. They're automatically transcribed for me. Now, I'm told that people don't actually use voicemail in Japan, so I don't know if this product will be launching here anytime soon. Finally, our third big product is called 1-800-GOOG-411. And that's a free telephone directory assistance hotline that you can call in the US to get information about any business in the United States. So we've got plenty of time, so I thought I would show you a video of what we're working on next. This is a top secret video about our next big voice search product. Did I hit the right one? Yep. I was hoping to leave some time for questions. Unfortunately, I don't know if we have a microphone set up so that the translators can hear you. If people want to ask questions in English, I can repeat them and try to get them translated. Otherwise, I'll be having office hours at noon just in the room outside of here. So any questions? So the question was, how soon do we expect to have multi-language support for the voice API? So any language I speak, it will automatically be identified, and I won't have to sort of manually set the language. So the answer is, I wish I could give you an answer to that. That's certainly something we'd love to do. But I don't have a date to announce for when we might have something like that. But that's certainly something I'd like to do. Now, one thing to note about that is that we find as we build more and more languages, and you probably see this yourself, that many languages incorporate a lot of English into them. So we do try hard to make sure, in Japanese, that you can mix some English with your Japanese, at least for search. So English words which we commonly see in search are added into the language model and can occur right beside Japanese words. And that's where the acoustic model comes in, because Japanese speakers pronouncing those English words are often pronounce them in a completely different way from the way English speakers do. So we sort of have a specific acoustic model for Japanese speakers of English. But yeah, that's something I'd love to see. It's kind of a scalability issue of, do I send the audio to, 100 different servers at the same time and get the recognition result back and try to decide? Do I listen to a little bit of the audio and try to decide at the beginning? So there's, it's certainly technically feasible, but sort of doing it at a Google level scale becomes difficult. Any other questions? Okay. Sure. I'm sorry, I missed the last part. What do I think about? Translation issues? Oh, localization? So the question is about voice actions, and in particular about these small commands you have to give. We call them carrier phrases, is sort of the technical jargon, but these are the little phrases you have to say to make your command work. Things like send text, navigate to, send email, the things I've highlighted in blue on the slide here. And I guess the question is about localization of them and how they should work in other languages. So I should say at the moment, voice actions are only supported in English, in part because we're trying to figure out exactly that problem of we've got them in English now, how are we going to make them work in 15 languages or however many languages we end up having in a few more years. And so that actually turns out, and even to do it in English, it's a very tough problem because you can teach the user to say send text or send email, but it can be very brittle. So if the user says send a text or send the text or send an SMS text, then does that work? The only way to answer that question is by looking at real data. So our approach has been to launch something that works with a few phrases, and then to try to rapidly understand what are the other phrases that people are using and try to add those to the product. But as you can see, that's time-consuming and difficult to do in a lot of different languages. So we're trying to automate that process as much as possible. And when we have a good handle on how to automate it, we'll try to release it to as many languages as possible. We think it's a really cool and useful feature, but it's going to be a fair amount of work to localize it. And we certainly don't want to make you have to speak English. We want you to say whatever's natural in your language. And in some languages, these phrases might come at the end of the command, right? So it's actually pretty difficult. But yeah, so we're working hard to try to get this in more languages and localize it. But it's going to be a fair amount of work. Any other questions? Sorry, can you say that again? Okay. I see. So the question is, how long of a sentence can be recognized? 30 seconds, 30 minutes. I don't know if I have an exact number on that at the moment. It should be on the order of, I think maybe around one minute or so is probably the most we can handle at the moment. But that's, again, something we'd like to look at as just to look how users are using the product and see if we need to support longer sentences. I think at the moment users are probably hesitant to speak for half an hour because they won't see the result until recognition hypothesis until after they finish speaking. So it's pretty daring to speak for half an hour and hope that we will get it exactly right at the end. Oh, the voicemail transcription system. Yeah. So the voicemail transcription system is different, and of course, on that you can speak for a long time. I don't have. So that's a different system because it works offline, right? So the user, somebody leaves a voicemail, and then we don't have to instantaneously transcribe it, right? So if it takes us a minute to transcribe it, that's probably okay. So it's a little different from the mobile phone situation where I speak and I want to get a result immediately. So it's more feasible to handle longer audio there. Honestly, I don't know if we have a hard limit in that product. If you call up and try to speak for 30 minutes, I think we'll try to transcribe it, but I don't know honestly what the limit is. So the question is TTS, or text-to-speech. Are we building that into the API? So there is a different TTS API on Android. And I have to admit, I'm not an expert in that API. I know that you can use different TTS engines on Android through that API. But yeah, I have to admit, I don't know all the details of it, but it does exist. So if you've used our Google Maps navigation product, you'll hear that uses a lot of text-to-speech, and I believe that's just using a public API that's accessible to anybody. Any more questions? So the question is about voice actions, and do we really need to ping the Google Voice server to make it work because there's a finite number of them? So certainly for the voice actions part, send text, send email, navigate to, listen to, go to, just that phrase could certainly be recognized on board on the device. But once you say send text to Claire Homberlin, hey, are you coming home? That becomes much more difficult to do that entire utterance on the device. So you could imagine a sort of a two-step system where I say send text, and that sort of gets recognized on the device and then fires up our network-based speech recognizer to do the rest. The problem with recognizing these complex sentences on board on the device is that our models are huge and take up lots of memory and lots of compute power, and so they're difficult to fit on a mobile phone at the moment. Okay, one more question if anyone's got one. Yeah. So the question is about navigate to on the device and using voice commands. So I guess I don't quite understand your question. Oh, like starting any application, you mean? That's certainly something we're interested in. And to tell you the truth, there's actually an application on Android Market that uses our voice input API that gives you exactly that capability. So you can say open email, open SMS. So that's we're intrigued that someone built that application, and it is an area we're interested in. But again, there are potentially thousands or tens of thousands, hundreds of thousands of different applications on your device. But so that's something we're thinking about, but it's not in this version of voice actions. Okay, thank you very much. And if you have any more questions, please come to my office hours following the talk, and I'll be happy to talk more.